All right, so today what we're doing is we're looking at scale drawings. So scale. All scale is the ratio between two sets of measurements. So the ratio between two sets of measurements. An example of this is in the back of the room, there is a map. It is a drawn map. It is a scale map of the International Space Station. The scale of that map is 1 to 200. So if you were to measure 1 centimeter on that map, it would be 200 centimeters in real life. If it was 1 foot on the map, it would be 200 feet in real life. So it is a scaled map of the International Space Station. Let's look at how to find scale given a model. Let's take 1, 2, 3. Let's pretend that that's 3 inches. Just pretending. And then 1, 2, 3, 4. We're going to pretend that that is 7 inches. So there's our rectangle. And the scale for this figure is 2 inches to 3 feet. So what this means is that every 2 inches on our map is actually 3 feet in real life. So 2 inches on the map is 3 feet in real life. What we need to do is figure out this rectangle. What is the length and the width of that rectangle in real life? So I'm going to first look at the length. Looking at the length of it is 3 inches. I need to figure out, based on our scale, what it'll be in real life. So the first ratio that I'm going to write, the ratio between two measurements, is 2 inches to 3 feet. All I did was write down the scale, 2 inches to 3 feet. My top number represents my map. My bottom number represents my actual. So in my second ratio, I'm going to compare my map to my actual. That actual is what we're looking for. How do I find that missing value? Kayla? So I'm going to multiply diagonally, divide by my leftover number, and when I get that, it gives me 4.5. So 4.5. Yes, ma'am.
Which is half of 2 inches, so half of 3 inches would be 1.5 times 3 plus 1.5.
Yeah, you could do that. You could find the difference there and then add it onto the bottom. You could do it that way also. This will work in every single problem and be more of a consistent way of explaining it, but that'll work also. Your way might get more difficult with fractions and decimals if we do like complex fractions. but it's definitely one approach you could use. To find the actual distance of our width, I'm going to first use our scale, map distance over actual distance. The width is 7 inches. So is it going to go on the top or is it going to go on the bottom? It's going to go on the top. This is my map distance. This is my map distance. This is actual. This is going to be my actual. I don't know my actual yet. I have to multiply diagonally, then divide by my leftover number. 7 and 3 is 21. 21 divided by 2 is 10.5. Or you could think of it as 10 feet, 6 inches. So what's the area of this actual figure going to be? Area of our actual figure. How do I find area, Bronwyn? Length times width. So I'm going to do length times width. So what's 4.5 times 10.5? Morgan? Yep. 4725. And that is feet squared. Don't forget that your area is always squared. So this is how you take a map measurement and turn it into an actual measurement, which is what you'll have to use when you're changing scale. This is going to be a very common type of problem because we're going to take a scale, change it to its actual, and then change it to a second different scale. So there's a company that made a tablet, and they wanted to make a promotion for the tablet, so they had to come up with these little posters for the tablet. The scale that they used for the tablet is 1 centimeter, is actually 4 centimeters in real life. So they drew 1, 2, 3, 4, 5, 6. We're going to pretend that that's 6 centimeters. It's 1/4 inch graph paper, but we're going to pretend it's centimeter. So 6 centimeters by 9 centimeters. So the scale here is 1 centimeter to 4 centimeters. And they're coming out with this new kind of promotional material, and they need to fit more information on the same size piece of paper. So now they're going to have 1 centimeter to 6 centimeters. So they're changing the scale from 1 centimeter to 4 to 1 centimeter 6. Is the new drawing going to be smaller, or is the new drawing going to be bigger? I'm going to give you a minute to think about that. All right, so you've had a minute to think about it and then share with the people around you. What do you think? Is our new drawing going to be smaller or bigger than that original one? Abby? Why?
Kind of like, the bigger ratio, like, even though the numbers can be bigger, it actually is not because before it was 1 centimeter on the paper, 4 centimeters on the tablet, but now it's like the tablet is,
So you're...
I know it's smaller, it's hard to explain.
No, I know exactly what you mean. So you're saying it's getting smaller And you're saying that 1 centimeter here, I'll use my pen. So 1 centimeter here, you're saying is going to be kind of a different than 1 centimeter over here. You're saying that here, this distance represents 4 centimeters on your tablet, but here, this distance represents 6 centimeters on your tablet. So what it's saying is that like that distance is eating up 4 centimeters of your tablet. So it's kind of shrinking it 4 centimeters this way. Here, it's shrinking it 6 centimeters this way. So that's why you're saying it's going to get smaller.
Yeah.
Does that make sense?
Yeah, I get it.
So you're actually stuffing more distance in the tablet into the same amount of area. So here represents 1, 2, 3, 4 centimeters of my tablet. This represents 1, 2, 3, 4, 5, 6 centimeters of my tablet. So this distance here measures more than this distance right here. The first thing I want to do is figure out what's the actual measurements of this new tablet. So the tablet itself, our scale, we're going to find the length of our tablet. The scale is 1 to 4. So 1 centimeter equals 4 centimeters. So the top is the map, the bottom is the actual. So when I'm finding the top, my map is going to be 6 centimeters. I'm looking for the bottom. Map distance on top, actual on bottom, map distance on top, actual on the bottom, multiply diagonally, divide by my leftover number. So what is the actual length of that tablet? Ty?
24 centimeters.
So that is the actual length of the tablet. Now let's find the width of our tablet. Our ratio is 1 to 4. The width here is 9 centimeters. Is the 9 going to go on the top, or is the 9 going to go on the bottom, Naya? Absolutely. Because it is the map distance, we're looking for the actual. So what is the actual width? Emily? Outstanding. So now we have our old scale map. We have our actual. Now we have to make our new one. So for our new one, the length, our scale changes. Instead of 1 centimeter to 4 centimeters, it's now going to be 1 centimeter to 6 centimeters. What do I do now that I'm at this step? I have my old map, I have my actual. How do I change it to this new one? Kayla? You want to put 6 on top here? So this number right here, this 1 to 6, represents our new scale. Are we wanting to... Because our goal here is to create the new drawing for the new advertisement. So how do I figure out what to draw for the advertisement? Do I know the actual length of the thing? Yeah, I know that the actual length is 24 centimeters. So how do I figure out what to draw it on the map? Ty? 1/4 of 24? Where would I put, so my map distance is on top, my actual's on the bottom, my map distance is here, so my actual is 20 here. So does 24 go on the top or the bottom of this new ratio? Go on the bottom. My goal is to find my new map distance. It's the reverse of here. Here I knew the map, I'm finding the actual. Here I know the actual, I'm looking for the map. Multiply diagonally, divide by my leftover number. So what is that going to be on our new map? 4. Now we'll find the width. Our new scale is 1 to 6. Says it right there. 1 centimeter to 6 centimeters. We want to know what the map distance is going to be. We know that the actual distance of the tablet, or the actual width, is 36. Multiply diagonally, divide by my leftover number. So what is going to be the width of our new, Sophia? 6 centimeters. So the length will be 4. 1, 2, 3, 4. And the width will be 6. 1, 2, 3, 4, 5, 6. This is a very common type of problem because they're asking you to go from a map to actual, and then from an actual back to a map. I'm going to have you do one on your own. All right. You're going to start with a scale of 1 centimeter to 3 feet. So 1, 2, 3, 4, 5, 6. So 6 centimeters by 1, 2, 3, 4, 5, 6, 7, 8 centimeters. No, this is the map. The map is, yeah. So you're changing your map to actual distance. So this is your map. Then you want to change the map to be 1 centimeter to 6 feet. So redraw that with a different scale. For those of you that are struggling with a place to start, remember that your ratio here is 1 centimeter over 3 feet. And that is your map distance to your actual distance. You're looking for the actual distance. You know your map distance. For this one, 1 centimeter, 6 feet. That is your map. That's your actual. You will know your actual. You're looking for the map. All right, so what is going to be the actual length of your figure? Nevaeh. Perfect, because it's a map. You do 3 times 6 gives us 18. Multiply diagonally and divide. So what's the width of this going to be in real life? Emily. So this is 8 centimeters on your map, so it'll be 3 times 8 divided by 1. You still got it, though. Morgan? You're really, really close now. So 18 in real life, 24 in real life. So now in our new one, the length here is 18 feet in real life. So I'm going to put 18 feet here. 1 times 18 gives me 18. 18 divided by 6 gives us 3. So that length right there will be 1, 2, 3 centimeters. And what will be the width of our new drawing? Bronwyn? B4. 1, 2, 3, 4. It is quite a bit smaller. And we got that by taking the actual distance. 1 times 24 divided by 6 gave us 4.